All right, everyone, please get your booklets out. Turn to page 9. And if the teacher can pause while everyone's getting their booklet out, that would be great. Okay, so in the last 3 lessons, we were learning about the types of transformations that parabolas can have. So we were learning that a parabola can have a vertical translation, it can have a horizontal translation, and that it can be stretched and reflected, which I can't do with my cursor. So it can be upside down, it can get narrow, it can get wide. Okay. The only point that we had the tool to draw so far has been the vertex. Okay. So today I want to teach you how to graph. And in doing so, we need at least 3 points, right? So graphing, we need at least minimum 3 or more points. Okay, 3 or more points gives us a sense of what the parabola will look like. Okay, the first method I'm going to teach you is called using ordinate differences. I call this the step pattern. Okay, so write down step pattern because that's what I will probably refer to it as. Okay, and I want you to look at this parabola, draw a dot on the vertex, and now go to x equals 1 and find the dot at x equals 1. Go to x equals 2 and find the point on the parabola at x equals 2. And find the point at x equals 3. Do so on the left side of the parabola. So at x equals -1, x equals -2, x equals -3. Now we are going to, so far we've been going 1 across each time to get the next point. So when I went 1 to the left or to the 1 to the right, how many steps up did I go? Well, I went from 0 to 1. So I went 1 up. When I went again another 1 across, so from x equals 1 to x equals 2, how many steps up did I go this time? It's more than 1. Let's count. 1, 2, 3. I went 3 up. Okay, let's go 1 across again. Okay, and go up, 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 up. And let's count the steps. 1, 2, 3, 4, 5. Do the same thing on the left side. So we're going to go 1 across to the left each time and then count how many steps up are we going. And now because a parabola is symmetrical, you might be realizing that we're going up by the same amount, right? And that's because parabolas are symmetrical. Now, what do you notice about these numbers? So when we're always going 1 across, but as we go 1 across, we are going 1 up, 3 up, 5 up. If we went 1 more across, how many points up would we go? 1, 3, 5. What's after that? What's the pattern? That's right, 7, 9, etc. So this is what I call the step pattern. The step pattern tells us how many steps higher is 1 point from another. Okay. we're going to practice this, okay? At what point do we have to start? That's right. We have to start at the vertex. Okay, so in order to graph using ordinate pairs or using step pattern, we must first graph the vertex. That is the only place from which you can start the step pattern. Okay, so remember, the vertex is going to be your H and your K. Then we're going to look at the A. So if A equals 1, if A equals 1, we're going to go 1 to the right, 1 up. Another one to the right, 3 up. Another one to the right, 5 up, and etc., etc. This is the base parabola. Actually, well, this is just when A equals 1. But what if the parabola opens down? Right, so in that case, A equals -1. So if A equals -1, we don't want our points to go up, up, up. We're going to be going down, down, down. So 1 to the right, 1 down. 1 to the right, 3 down. 1 to the right, 5 down, etc., etc. Lastly, if A does not equal to 1, if A does not equal to 1 or -1, right? Like if there's a stretch or compression, we need to include the stretch factor. The stretch factor is whatever your A is. Okay, your value of A is the stretch factor. Like we'll say, oh, it's being stretched by 2, right? So in this example, when A equals 2, that means the parabola is being stretched by 2. So how do I stretch something? Well, I'm going to multiply it. So watch this. I'm going to go 1 to the right, and instead of going 1 up, I'm going to go 2 times 1. So I'm going to go 2 up. 1 to the right, 2 times 3. I'm going to go 6 up. 1 to the right, instead of just 5, I'm going to go 10 up. Okay? So let's practice this. Using the method of ordinate differences, graph the following quadratic functions. So we're on page 10. The first equation we have, I'm just going to rewrite it. X minus 4 squared plus 5. I'm still going to write out my AHK. My A is -1. My H is +4. My K is 5. Okay, step 1, find the vertex. And we remember the vertex is H comma K, so it's going to be 4, 5. And let's go ahead and draw that vertex. So we go 4 across, 1, 2, 3, 4, 5 up. Okay, and let's label the vertex. 4, 4, 5. The second step is to figure out our step pattern. And so whatever our A is, we're going to multiply 1, 3, 5 by the A. Okay. Multiply. So in this case, if my A is -1, I'm going to go -1 times 1, 3, 5, blah, blah, blah. And so that means that my step pattern will be -1, -3, -5, -7, etc. Okay, so what do I do with this? Remember, the step pattern tells me how much to go down by. I always go one across, and then I change how much I'm going down by, right? So I'm going to go down by -1, down by -3, down by 5, down by 7. Okay, always going one across. Okay, so I start at the vertex. I'm going to go one across, and the first thing is one down. One across, 3 down. Here, I'm going to make this bigger. So one across, one down. One across, 3 down. 1, 2, 3. One across, how many down? 5. 1, 2, 3, 4, 5. And I don't have space to go 7. Because a parabola is symmetrical, I can now reflect those points over the axis of symmetry. Right, so one across, one down, one across, 3 down, and one across, 5 down. And now, check this out. 1, 2, 3, 4, 5, 6, 7 points. This, my friends, is a graph. Now I'm going to, as smoothly as possible, draw my parabola with arrows through these points. And I'll label the parabola. Y equals negative x minus 4 all squared plus 5. Review. We draw the vertex. We figure out what the specific step pattern is for this parabola. And that allows us to find the next dots, the next points. Let's try it when we have a stretch. Okay, so in this parabola, let's write down the AHK. My A is -3, right from here. My H is -2, and K equals 7. Step 1, find the vertex. So vertex just depends on H and K, right? My H and K. Let's draw it. We're going 2 negative, 7 up. 1, 2, 3, 4, 5, 6, 7. So there's my vertex. I'll label it -2, 7. In the second step, let's figure out the step pattern. So I need to multiply my A. My A is -3. And I'm going to multiply it by the original step pattern, 1, 3, 5. So my step pattern becomes 3 times -1, that's -3. -3 times 3 is -9. -3 times 5 is -15. So that means we're going to go 1 across, 3 down, 1 across, 9 down, 1 across, 15 down. Let's see how many we can reach. Okay, so starting at the vertex, we're going 1 across, and now we're going to go 3 down. 1, 2, 3. 1 across, 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we don't have space for the 15. Let's reflect those points over the axis of symmetry. And so we have a 5-point graph. And we can connect the lines with as smooth of a curve as we can. And we can see that this parabola is narrow, right? Because we did stretch it. So we can see how that stretch makes sense mathematically because we're multiplying every y value by 3. So we're making it taller per se. Now, what would happen if I had an a value that was a decimal, right? Something like 0.5. So in that case, my step pattern, I would multiply it by 0.5, right? So 0.5 times 135. And so my step pattern would be 0.5, 1.5, 2.5, etc. Right? So what's happening is now the y value is not growing as quickly. And that's because the parabola is compressed. So for your homework for this section, you're going to graph these equations. Now, folks, ignore the textbook instructions. Just use the equations, the functions given. Okay, so all you're doing is you're graphing these functions on graph paper, absolutely. Okay, let's get to the next part of the lesson.